Session of Back Porch Forestry. I'm Dr. David Merker, Extension Forester with the University of Tennessee. We've had quite a run with these Back Porch Forestry sessions, gaining viewers on a regular basis and a growing number of subscribers too. I encourage you to subscribe if you find these valuable and interesting. Back Porch Forestry essentially are non-formal educational sessions trying to reach landowners and foresters and basically anyone with interest in trees, forests, and forestry. I'm calling these 30-30s, roughly 30 slides in about 30 minutes. We're in the dog days of summer at this point, so I'm having to record these early in the morning. The screen might look a little bit foggy because of that, but it's getting pretty hot out. So today's topic addresses the issue of tree diseases. The true experts in tree diseases are not foresters. They are pathologists and arborists. I'm a forester, so I'm just going to sort of give you a cursory look at 10 common tree diseases that we find in the region. We'll talk about the symptoms, the mode of action, and the seriousness of each. I want to remind everyone too that your local county extension office is a great resource for identifying both insect and disease problems as they relate to your property. And also the county agents have access to the UT diagnostic lab. If it's something they can't identify, it can then be sent on to our lab for further review. So I encourage you to settle back into your Cracker Barrel rocker. Maybe get yourself a glass of lemonade and a pad of paper if you want to take some notes. And I'll share the screen and we'll get started. Back Porch Forestry. These began on my back porch during the COVID-19 crisis, and they've sort of continued since then. So today's topic is tree diseases, something old, something new, and like I said with the insect session, maybe something borrowed and something blue before we get done. I want to begin with just kind of a general overview of some symptoms, some common symptoms of tree diseases, things that you might notice that just don't look right on your trees. And one of the first things that I notice that I look for is I come out to inspect a tree that's maybe under stress is the very tip of the crown. Is the crown thinning? So as I slam my car door and I begin walking to the tree, before I even reach the tree, I'm looking at the outer perimeter, the terminal growth on the edges of the crown, because when a tree is under stress, quite often what it's going to do is it's going to recall its resources inward and downward and try to keep the core of the tree alive. So that's a telltale sign that the tree is having problems if it's a thinning crown. Chlorotic leaves are another problem. In other words, yellowing. It's not normal for trees to be yellow. They should be green while they're photosynthesizing, and so that can be telling us something. If there are blemishes on the leaves, insects and diseases both cause blemishes on leaves. It's a normal thing, and quite often people get too concerned over this because the trees typically overcome that, and I'll talk about these as we go through it. Now, mushrooms growing on the stump or from the roots or of branches are not normal, though, and that is an indication that there's some internal rot, and it may be too late to save the tree at that point. Also, seeping fluids coming from the bark or branches, and then just loose bark as well can tell us something about the tree. So let's begin these 10 tree diseases that I wanted to address today. And I begin with anthracnose. Anthracnose, I've chosen this as number one because it's a very common disease. And for the most part, it's not concerning, but it does concern people when they see it. And you'll notice that the leaves fall off the tree during the spring of the year, and there's this brown necrosis or dead tissue on the leaves. So let's delve into this a little bit more. Regarding the mode of action, anthracnose is a weather-related foliage disease. So when we have warm, moist conditions, in other words, very humid in the spring of the year and the temperatures start reaching 83 degrees or so, that is prime for the development of anthracnose. It is most common, at least in our region, on sycamore. So we hear a lot about sycamore anthracnose. I'll get calls every spring related to that. You'll see it too on oak and maple, dogwood, on apple trees, and there will be a splotchiness or a brown necrosis on the leaves themselves. This is cell death. and that's followed by defoliation. So these trees that become infected then fall off, but it's followed by a reflush of new growth. At least if the tree's healthy, it will reflush from their dormant buds. And so once we get some hot, dry summer conditions, then it suppresses the disease. The tree will fully recover, and you'll hardly even know that anything had happened by mid to late summer. And so generally it's not viewed as being a problematic disease, but it is common. And here's some examples of sycamore anthracnose. You see it on sugar maple. Dogwood is quite common, and then oak as well. So kind of this blotchiness, this brown blotchiness, the loss of leaves, and then the reflush of leaves. But this disease is problematic, and its symptoms are very similar, and this is bacterial leaf scorch. And you'll notice a clear, distinct scorching of the leaves, and particularly red oak are susceptible, and I guess in particular pin oak, Quercus palustris. And for that reason, we don't recommend the planting of pin oak anymore, at least in urban settings, because the disease has caught on and it's killing a lot of trees. So I do want to differentiate, though. I say pin oak is highly susceptible. This top species here is what a lot of people think is pin oak. This is actually willow oak. And there's a difference between willow oak and the bottom one here, and that's pin oak. You'll notice the very distinct lobes, narrow lobes that you see in the pin oak, and that bottom set of lobes has kind of a sharply right angle to the main stem. But it was commonly planted in the 60s, 70s, and 80s in urban settings, and now those trees are beginning to decline. The mode of action, excuse me, of this species, or of this disease, is that a bacteria is introduced by a leaf hopper that actually plugs, the bacteria plugs the water conducting xylem. And so you'll see the picture to your right. It's a very colorful little critter. It's candy striped leaf hopper. And it's interested in the sugars from the tree, but it introduces this bacteria as it's piercing and sucking that causes the damage. So there's a death of tissue that occurs along the leaf margin. In other words, the outer portion of the leaf. It leaves a scorched appearance to it. And it occurs when sufficient water is not capable of reaching the margins of the leaf. The leaves then will fall off prematurely. You'll see it in the middle of summer. It's very concerning when you see leaves at the bottom of your tree. And the disease progresses, and it's eventually going to kill the tree within about 3 to 5 years. There is no cure. There is some preventative work that can be done if you have pin oak in your yard, that arborists might be able to inject it to protect it. But once it has it, as I understand it, it's going to die. And so here's some examples of the symptoms. You'll see a browning from a distance. You can see the scorching appearance. There it is, a closer look to the scorch, and you know it goes from the outer portion inward. Once the leaves fall off, it leaves a thinning crown, and you'll see a cluster of leaves at the base of the tree during the growing season, which of course is not normal and is concerning. I want to mention powdery mildew because it's a very common disease, and rarely is it of great concern either. But it obviously gets its name because of this powdery appearance that it leaves on the trees. Perhaps you've seen this on some of your foliage. The mode of action is this disease develops on warm days that are followed by cool nights. So the combination of those two is prime. And then you'll get a dry day then that will vector the spores from one tree to another, and so forth. And so the spores then at nighttime absorb enough moisture to then germinate and cause infection of the leaves. And so the fungi feeds on sugar in the leaves. This causes vigor, and also this powdery appearance that forms on the leaves blocks the sunlight, which of course is needed for photosynthesis. So it can weaken the trees, at least temporarily. Well, what you'll find is that improved ventilation helps this disease, at least helps eliminate the disease through spacing and pruning. Good ventilation, we can't stress that enough in your landscape. Just have some airflow through that can dry up leaves during the night conditions and so forth and prevent this. So rarely it's a lasting problem, and it's resolved by warm weather. So that's what it looks like as it's infecting the leaves, and close up as it germinates and begins to grow. Thousand cankers disease is something that was introduced to our region, at least eastern Tennessee, about 10 years ago. It's a species that's specific to black walnut, Juglans nigra. It's not widely found, at least not in forest settings. It tends to be more either in urban settings, or maybe if there's a walnut tree out in a pasture or something like that. Oftentimes these trees are growing off-site, and so they're under stress anyway. But the mode of action is the disease actually has a combined activity. So the walnut twig beetle feeds on the tree itself, but then it introduces these fungal spores. Let me back up. The walnut twig beetle feeds on the fungus that it introduces to the tree. And the fungus then is carried into the phloem, and that eventually leads to cankers. And so these cankers eventually girdle the stem, and that leads to yellowing of the foliage. Normally, that's the first thing that you see is the yellowing of the foliage, and the tree dies because of block translocation. So to repeat, the beetle carries the fungus, and it's the fungus then that creates these cankers that eventually kills the trees. So there's the beetle itself, and you'll see in the upper right-hand picture, the size of it is very tiny, very much like the ambrosia beetles that we talked about in our insect session of Back Porch Forestry. And then down here in the lower left, that's the fungus that's been introduced. It's been feeding, then this causes the canker, and the cankers enlarge, and so this brown tissue is dead. You'll see a little bit of living tissue still left in here, but what you'll notice then is that the water, the sugars can't be translocated through the tree, and it ends up killing the tree. Black knot disease is very common particularly with the prunus species, trees such as the wild black cherry, even the cherry trees, ornamentals that you'll find in your yard, or plum trees. And it's very distinct, has this knotty appearance, this black knotty appearance to it. Begins small, and then it eventually expands and gets pretty large. And in time, in most cases, it's going to kill the tree. And so here's the mode of action. It does cause this lumpy growth that I was referring to on the twigs and branches, and these progressively just grow and get worse and worse. The infection occurs on new shoots during periods of measurable rainfall in the spring of the year. So when we have temperatures around 72 degrees and it's raining, that's when this disease wants to develop. The tree then responds pretty aggressively to try to grow around this infection, and hence that leaves kind of a warty appearance. And then eventually secondary insects can invade, particularly if you have open wounds on these galls. They're after the sugar that's been released. And of course that can lead to other problems, vectors of other diseases. So gradually the tree loses vigor, and normally it's going to die. I think cherry species in general should be reconsidered in landscape settings because of this reason, unless you have some really good soil and you intend to really take care of the trees, because cherry in general are species that require good site to grow on. We don't want sites that are unusually dry or with shallow soils. So many of our homes are built on sites that were once row crop fields or pastures, and the soil's been eroded and depleted of nutrients and so forth. And so it's just not a good tree to select in most cases in ornamental settings. The Dutch elm disease has been around with us in the United States since the early 1900s. And so it continues to exist, and elm trees continue to grow, but eventually they'll get old enough and they'll succumb to this disease and die. But in the meantime, they're able to produce seeds to continue growing young offspring that eventually will get the disease. And so it's not causing the elimination of the species, but it does affect it in the long run. I do want to note, though, that you'll notice a scorching on the leaf pattern, and one thing that's really distinct as far as the brief recognizable features of the Dutch elm disease is that there will be this scorching from the edge of the leaf inward, and then there will be this distinct yellow line or band that separates the scorching from the green, and that makes it unique from other scorching type diseases. So the European bark beetle adults tunnel into the cambium of a tree and then feed, and they lay their eggs. And so you'll notice here's where the eggs have been laid, and you'll see these tunnels that the larvae feed in. And then what happens is that the beetle emerges as an adult, and oftentimes if the tree has been infected, it will carry with it these sticky spores then that transfer the fungi to other healthy trees as they go to find another source to feed on. But the fungus, it's the fungus that ends up killing the tree, not the insect itself. And one of the things that's distinct, if you were to take a juvenile branch that's been infected and slice it open, you'll see this brown ring that occurs on the elm trees right here in that cambium area, and you'll see it if it's cut longitudinally. You'll see it there too, that brown ring. So a close related disease that also affects elms is elm yellows. As the name implies, the leaves actually turn yellow and then fall off, and so they don't die on, they don't brown up on the tree themselves. They fall off while they're still yellow, as I said, closely related to the Dutch elm disease. But it's spread by the white-banded leaf hopper, and you can see that photo in the lower left-hand corner. And this hopper sucks on the phloem of the leaves, essentially trying to get the sugar out, which is what so many of these insects are trying to do. And so that tends to spread it from tree to tree to tree. The disease can also be spread by root grafting. So if you have an infected elm adjacent to a healthy elm, it can actually reach the tree that way as well. So the hopper introduces a bacteria that travels through the phloem and then kills the roots first, and then travels up the tree. The leaves, as I said, turn yellow and then brown, and then they curl up. Some of the key identifiers is that the leaves will drop off, as I said, while they're still yellow, and there will be a noticeable wintergreen odor that emanates from the bark. It's a rather sudden death, dying within about 2 weeks. Artist conch. Most of us are probably familiar with this, might not have known what it was called or what it is caused by, but this is the fruiting body of a disease that enters in through trees, and these conchs exude out, and they can live for quite some time, sometimes exceeding a decade or so old. The spores then from the conchs essentially land on dead wood or on wounds of living trees, deciduous trees. And so each conch, it's been told to me that each conch can release over 5 trillion spores per year. So that's a lot of spores. And that's precisely why we tell landowners that they really don't want to prune their trees until the winter months, because these spores, particularly in the late summer, early fall, are quite prevalent in the air, and they're just looking for a host. And if 5 trillion are released per conch per year, sooner or later they're going to find a wound on your tree. But by winter time, these spores have all settled out, landed into the leaves, and they're decomposing. But so that's a better time to prune, so that the spores won't land on a new pruning wound. Fungal strands then feed on the decaying wood once they find the wound. And ideal conditions for growth are about, well, in the middle of the summer, 70 to 95 degrees and 70+% humidity. And so remember, the conch is the fruiting body that produces the spores. So here's the spores. This is the fungal strands, and this is the conch itself. And each one of those represents a growth ring, just like aging a tree. So you can see, if you were to cut the conch in half, you can count the rings. 1, 2, 3, 4, 5, 6, 7. This conch is about 8 years old. And then I don't know this for sure, but it seems logical that it gets its name because artist conch, because it does have artistic value. You can use devices to score into these conchs, and artists like it for that reason. So Hypoxylon canker, we've probably seen this, many of us, and not known what it was or what causes it again. So the mode of action is that the hypoxylon canker essentially takes advantage of trees that are already stressed and are already on the decline. They're dying. And so the hypoxylon canker doesn't kill the tree. It takes advantage of tree that is dying. And why is the tree dying? Well, there's any number of reasons for that, but we tend to see it in forested settings, this hypoxylon canker, on south and southwest facing slopes following drought. Particularly if the stands have been overstocked. So there's too many trees, not enough moisture on a dry southwest slope, and so something gives. And you can also find it on sites where you've had a great deal of soil compaction and root diseases and so forth. And so the infection originates then when the spores come into contact with stressed tissue, and these fungal mats grow beneath the bark, essentially causing the bark to pop loose. So it just pops off, and as it does that, then it exposes the inner cambium of the tree. Here's some examples. This is a fairly fresh infection of hypoxylon canker. You can see the bark is just beginning to slough off. Here's some a little bit more advanced where the fungus at this point has actually died, but the bark is gone too. And then a larger tree here, and I've thrown this in here because the cluster of bark that you'll see at the base of this hypoxylon canker. Now, I want to make a point here, although this is obviously very concerning, bark at the base of the tree is not always a concerning issue. And here's an example. I get calls on this every spring, particularly bark that has loose scales like sycamore or perhaps hickory, or even a lot of the white oak have scaly type bark rather than corky bark. And essentially what's happening is that the inner phloem is growing, that new bark is growing, and so it's flexible, but the outer bark is not flexible. It's static, and so as it grows, it can sometimes begin to pop loose, and particularly if we have a windy night or windy day. And so a healthy tree is growing rapidly, the cambium is expanding rapidly, and the outer bark is not capable, is not flexible, and along with the wind, it'll pop off, and you'll see a cluster of bark plates around the base of your tree, normally along about May or perhaps in early June. And that can actually be a good sign, an indication that the tree is growing rapidly. This is more in yard settings than perhaps in forested settings. And then I complete with oak leaf blister. The brief recognizable feature for it are these obvious blisters that you see on the surface of the leaf. These blisters then will oftentimes turn into a round bulge as the growing season advances. And this is a disease that tends to affect mostly red oaks, at least in our region. Its mode of action is it's active during cool, moist conditions. That's what's required for this disease to spread. And it only affects young emerging leaves in the spring. And so there's really only one infection period that occurs in late spring, and the spores essentially are blown from leaves to the buds. And the spores will remain on these buds until next spring, at which time when the buds open up and the leaves begin to flush, they pick up this disease as they're flushing off of the buds, and it will leave this blotchy or spotty appearance to the leaves. But it's really not a problematic disease. It's concerning, but the tree will continue to photosynthesize, and it can live symbiotically with this disease just fine. So I want to make some closing remarks today of what we've kind of covered. Understand that some tree species are just inherently problematic to diseases and probably should be avoided in yard settings unless you're willing to do a lot of maintenance to maintain them. Pin oak is chief among them. We just don't recommend it, at least in our region anymore, because of the bacterial leaf scorch. Leland cypress are fast-growing evergreen trees that are great for screens. But in time, particularly if they're planted too close together, this gets down to that ventilation issue. They can develop diseases and die fairly rapidly. Sycamore is a tree that most people just try to stay away from because of the sycamore anthracnose that we talked about, but also they're very limby. They lose their limbs rather easily, and so you constantly have to clean up around them. And of course, there's a whole host of other trees that you might want to reconsider, talk to an arborist to know for sure. Often tree diseases are actually secondary to other issues. So the tree's been wounded, maybe it's been struck by lightning. Improper care, it's planted off-site. We planted a tree that has a taproot that won't grow on these hard pans, the clay hard pans that sometimes we find in yard settings, and just they're just doomed to cause you problems for a long time. And so match the tree to the site. Most tree diseases originate from fungi that is spread by wind, weather, or other insects. And so a lot of these things are just weather related, and there's not much you can do about it, but just wait for warm, dry weather. Once things warm up and dry up, typically, many of these diseases anyway will dissipate. So, and then I've mentioned proper ventilation. That just helps to avoid fungal problems. We move into our yard setting and we see these open areas and we think something needs to be planted there and there and there. to fill it up. And that's fine when they're young, but eventually these things grow up. And as they do, it just prevents good airflow, humidity builds up, and it leads to these problems. So in some cases in your yard setting, the real solution is to begin thinning some trees out to improve the ventilation and lower the likelihood of diseases. Well, that concludes this session of Back Porch Forestry. As always, there's a survey that I encourage you to fill out. You can either write this URL down, or I've got it posted back on the subject line under YouTube. And let me know your thoughts. And then also, as I mentioned earlier, don't forget that samples can be submitted to our UT Diagnostic Center. So if your county extension agent can't identify it, they can work with you to identify it and to see whether or not it's actually a problem or not that you need to be concerned about. So I hope you've enjoyed this session, and your glass of lemonade is come to the bottom, and you want to refill it again. So I encourage you to do that. And thanks again for your support, and we look forward to seeing you again in the future.